Hey, what's up, guys? Chung here again. And so this time, let's take a look at another classic problem here, number 78, subsets. All right, so you're given a set of distinct integers, return all the possible subsets, right? And then it's not the permutation of itself, right? Basically, it asks you to return all the possible subsets, right? Not just one, two, three, and or 1, 3 or something, right? So it has to be a sequence basically, right? And basically 1, 3 and 3, 1 is the same, right? It's the same subset, and 2, 3 and 3, 2 is the same, and 1, 3. Basically all the possible subsets from this from length 0 to 1 to 2 and to 3, right? So how can we solve this kind of problem, right? So we use a backtrack idea here, right? Basically, first, we're gonna have like the first while loop is to loop through from length 0 to length 1. Sorry, from length 0 to length of the length of the nums here. And for each of them, right, we try to do a backtrack, right? We try to mm, try each of the positions here, right? And from there we try again and again, right? And whenever they and while we're doing the backtrackings, we're also maintaining like uh current numbers, right? Current list. And whenever that list reaches our current uh length, either 1, 0, 1, 2, or 3, we just return that uh that current list. Right, so that's why we need the backtracking, because the reason being is that every time when we add uh, append like current numbers to the backtracking arrays, um, after finishing the backtracking recursive call, we need to remove it, right? I will I will show you guys later on. So let's do this, like length of the n, right? So first we're gonna get like the length of n, and then let's define a backtracking method here, right? Backtracking. Uh, so okay, let's implement the backtracking method later, right? So let's do this. So like I said, since we're going to basically to get all the subsets, right? Subsets for all the length, and the length is from 0 to the length of the nums, right? That's why we need to have like I in range n plus 1, right? So the reason we do n plus 1 is the we need the length n basically, right? And then now we're gonna have an answer to hold our final result here. So basically that's why I need to get like a backtrack here, right? Basically every time for current length I here, I call backtrack. And then here we'll be having like a current list, and at the beginning is always 0. I'm sorry, it's always empty. And since we're going to do the backtracking, right? So we're always moving forward, right? We're not coming back. So that's why we also need like a starting index here, so that we can every time when we add the backtracking method, inside of backtracking method, we know where's our starting point, right? So current list. And here in the end, we simply return the answer here, right? And now the critical part here is how can we implement this backtracking method, right? I think first, right? So if the length of the current list, right, equals to I here, right? So I is our current processing length. So I means we are trying to find all the possible subsets for the with length I, right? Then we just simply append our current the list to the answer here. All right. So that's the check. So if it's not the length, what do? We do a start. We do a for j in range uh, start to end, right? And we just do a backtrack, right? Backtrack. Sorry. So basically, if it is not has not reached the our desired length here, right? What do? We add we add the current we add the current number to the current list, and then we starting from there. We try all the possible ways again, right? That's why we do a current list. Oh, one more thing. So since we're doing this like reference, we need to make a deep copy of the subarray of the arrays. Otherwise, uh, later on, if we change the current list, all the answers we had previously stored added in the a answer variable will also got changed. That's why we do a deep copy here. So now we do a append, right? Append this thing to append the current number to this current array, right? And then we just pass this updated list into the backtracking itself, right? And remember the starting point will be j plus 1, right? And then the current list itself. Why that's why we keep the starting point here, right? Because we always want to moving forward, right? And let's see. And for example, we are processing length equals to 2, right? And we are at the let's say the current list is 1. We have 1 here, right? And then the starting point will be from 2 and 3, right? We have 1, 2, and 3. So the current list is 1. Now we need to start processing 2 and 3 here, right? So then first, okay, we start from 1 here and start from 2, right? And we see, okay, we see a 2 here, so I'm gonna append this 2 to the end of 1 here, right? And then I'm going inside here, and then okay, I find another a 1 and a 2, right? And once I come back here, right, you see that? So if I don't do anything with the current list, since we're still inside the for loop, right, and it will process the 3 here, right, and then it will append the 3 back again to this current list, right, which will be wrong, right? That's why after backtracking method, that's how this backtracking method uh, makes sense here, right? So after finishing these things, we just pop this thing, pop this like the number we just added to the current list, because for each of the element in this for loop, any of them should start with a identical clean start, right? That's why basically we just remove whatever had change we had made to this current list, because this current list is being shared among all the backtracking method here, right? So that's why after we processing 2 here, once it's finished, right? When it comes to here, before before going to the number 3 here, we will be removing this 2, right? And then when it's come to 3, it will be 1 plus 3, right? That's why we can keep track getting those like answers, right? Hmm. Okay, so yeah, I think that's pretty much it is. So and then we use this one to determine, okay, if we need to add this number to the end, right, to the final answers. So let's say if when we process 1, 2, 3 here, right, still, right, and I gonna I is gonna be 3 here, and then when it comes to here, uh, basically we'll be doing some like redundant work here, right? Because there will be only one result, right? So for all the other for loops and backtrackings, and when we reach here, the current list will be 0 and 1. Okay, let me think. Well, actually, you know what? Actually, do we really need this? And let me do a quick check here. Okay, you know what? Let's try to run it first. And okay, so this one finished. It passed. All right. Actually, while talking to you guys, I was hmm, one idea just came to my mind here. Just came to me. While we're pass while we're like when we are processing length 3 here, seems like we basically we will be also processing 0, 1, and 2 of the length. So, hmm, maybe, right? So let's see, the n is here, and okay, so let me do some quick testing here. So if I remove this thing, and instead of here, if I do less or equal than n, right? Will we get the same result? Let's see. Hmm, let's see. Yeah, here. So the starting point is also 1, right? Will we get the same result? Hmm. Yes, cool. So see, okay, that's what I thought, right? Basically, we don't need this for loop here because while we're processing the last array here, right? The last length, let's say for example 3 here, 1, 2, 3. While we're processing that, we are also processing 0 and 2. Sorry, 0, 1, and 2, right? That's why we can just simply remove this for loop. Instead, we're just processing as if we're only processing length 3 here, right? And then for anything that's, well, actually, we don't even need this. Do we need this thing here? No, we don't need this thing. Basically, every time we can just add here because it's bounded to the end, right? So yeah, we don't even need to check the length because we know the maximum length will be n. So this current list will never be more than n, right? And yeah, we just simply use this like backtracking method to try all the possible combinations starting from this current index, right? And every time we find a new, basically every time when we see go to the new go inside the new backtrackings, we know okay must be one of our result, right? And just we just add it to the answer here. Hmm. Every day learn something. Yeah, yeah. So this thing is redundant. We don't have to use that. Hmm. Cool, guys. I think that's yeah, that's pretty much it is I want to talk about for this problem. Yeah, yeah, it's good. I improved my solution here, right? By removing this like in redundant for loop here. So we only be doing this one backtracking method. Cool guys. I think thank you so much for watching the videos and I'll be seeing you guys soon. Bye bye.